Okay, is this thing on? The transmission from Europa's been a little spotty lately. Okay, there we go. Yo, it's your friendly neighborhood ET, Eliana Moore. I've been instructed by Dr. Mitra to teach you all about litmus tests and chemical indicators. I'm happy to oblige. To start, let's review some basics like what is pH anyway? pH stands for potential of hydrogen. In short, it's a measurement of hydrogen ions in a given solution. Water is neutral because of the dissociation it goes under, called autoprotolysis. As the water molecules split, they produce hydrogen cations and hydroxide anions. These two smash together into hydronium cations. Since the hydronium and hydroxide are produced in equal amounts, the solution is balanced, or as us proper scientists call it, in equilibrium. The scale itself ranges from 1 to 14, with 7 being neutral. Anything below that is considered acidic. Higher than that, and it's considered basic, like your best friend's ex-boyfriend. Each step is logarithmic, so going up a level means going 10 times higher or lower in strength. But why does any of this matter to us? Common applications of pH testing in the earth sciences occur in fields linked to environmental science. For example, soil analysis. Many common trees, such as cherry or magnolia, don't grow here very well in San Antonio due to the alkaline nature of the soil. Another can be seen in hydrology. Measuring a sample from a body of water would tell you what kinds of life could or could not survive in it. But how on earth does a simple piece of paper even change color to tell us these things? Let's find out. So, what is a litmus test in the first place? A litmus test is a low-tech test to observe pH in a solution. It uses a strip of paper coated in litmus, a compound derived from algae that changes colors in response to pH. In the presence of an acidic solution, it turns red, while in basic solutions, it turns blue. But how? It turns out a common beverage can provide some insight. Tea. The tea from butterfly pea flowers is used in a variety of trendy drinks on social media. You may have probably even drank one. I mean, I don't blame you. They are delicious. Anyway, litmus tests in these viral drinks both change color in the exact same way. For example, the pigment responsible in the change in the tea is anthocyanin, another water-soluble compound. See, both of these organic molecules have something called a phenol group. In low pH environments, the anthocyanin has a positively charged cation there. But as the pH increases, something called deprotonation occurs. Spoiler alert! Protons and hydrogen ions are the same. This throws the solution out of our precious equilibrium. Since the compounds have changed their structure, they will absorb light differently, which gives us the bright colors that we see. But how would we use it? Let's say you have 3 samples taken from a body of water, each from a specific area. 2 have a known pH, but 1 does not. If one sample in a similar vicinity has a different pH to the other, you could assume that there are contaminants in the water, and based on whether it shows as acidic or basic, what kind of contaminant it may be. However, litmus tests also have limits, and unfortunately, that property is also one of the many reasons why. If contaminants are what you're looking for, they're helpful, but only for general class. Litmus tests can't tell you how strong any given specific contaminant actually is. And since there are often multiple sources for them, class alone won't tell you where they may have originated either. Because of this, we normally use digital tools to measure the pH more precisely, then combine that measurement with other techniques like spectroscopy, where we can identify one from the other. But that's for another video. Thanks for tuning in to this transmission. Have a question? Future video idea? Feel free to shoot me a message in the comments or email me at elianamore2030@gmail.com. The links to my Instagram and other pages are in my bio, so feel free to say hi there too. Well, that's all the time I have for today. Until next time, stay curious. Saraba!